Fundamental thermodynamic variables of the atmosphere there are three. There's the pressure, density, and temperature. So pressure is denoted as small letter p, in this course at least, because sometimes people have used capital P. Density is denoted as rho, and temperature is capital T. Now we can apply the rates of change. That means how fast does this thermodynamic variable change with time using two different systems, which is the Eulerian system or the Lagrangian system, where the Eulerian is for a fixed grid system and Lagrangian system is for a grid that moves with the parameter under study. And what I mean by rates of equation is how fast does these things change with pressure, density, temperature change with time. So imagine that we can write dP over dt for the change in pressure over time is equals to the small change in pressure over time plus the change of pressure with horizontal distance or dx multiplied by the zonal velocity, the small change of pressure in the north-south direction or del y multiplied by the meridional velocity plus in the change of pressure with height or dz, del z multiplied with the vertical velocity component. Now we can also rearrange this equation if we want to calculate the change of, like I used the example just now, pressure at a certain location, del P over del T, by rearranging it by bringing the other terms on the other side, which basically said that the top and the first equations are the same. It's just what is the subject of the equation is what's different between these two equations. And just to show you what I mean and how we can use this equation, the rates of change of equation on any one of these fundamental thermodynamic properties, is just to substitute the said fundamental thermodynamic property into the equation. For example, dt over dt is equals to del t over del t plus u del t over del x plus v del t over del y and plus w del t over del z. This is the change of temperature with time, the small change of temperature with time, plus the change of temperature in the zonal or in the horizontal distance, multiply with the zonal velocity component, plus the change of temperature in the meridional zone, multiply with the meridional velocity component, plus with the vertical velocity component, multiply the change of temperature in the vertical direction. So when we add up all these terms, and it should equate to the change of temperature with time.